Hey guys, this is Mr. Grice for Algebra 2, Chapter 5.2 Notes, Day 2. Today we're going to be continuing our discussion on systems of equations. However, today our focus is on infinite and no solutions. You have seen graphs of system of equations where there are no solutions, those are parallel lines, or infinite solutions when the lines are on top of each other. Now we're going to see what that looks like when we're using the substitution method for solving. Okay? So our first definition is infinite solutions, and that's when the variables cancel out and the remaining equation is true. So after you substitute in, you solve, and if you're left with a true statement, okay, that means it's infinite solutions. Okay? And for no solutions, when the variables cancel out, and the remaining equation is false. Okay, when it's false, that's when it's going to be no solution. Okay? I'll leave this up for just another second. Otherwise, we're going to go ahead and get started on the bottom. Okay, we're going to do all of these together today. So our directions say to solve the system by using the substitution method. Okay, we've talked about doing it with graphing, and well, we don't have graphs, so we're not going to do that. Okay, so we always want to look to see what variable of the two equations is by itself, and y is by itself. And we know that y equals negative x plus 3. So I'm going to find where the y is, and we're going to substitute it in. Okay? So we've got 2x plus 2 equals 6. And remember, this is what we were talking about yesterday. We're going to take everything and plug it in, the negative x plus 3. Okay? So what we have to do is we're going to take this positive 2 and we're going to distribute. Okay? The 2x stays the same. 2 times negative x gives us negative 2x. 2 times 3 gives us positive 6. And we're left with 2x minus 2x plus 6 equals 6. Now our next step, if you're looking at that giant poster that should be somewhere in the front of the room or on the side, we have to combine like terms. Okay? So our like terms are the 2x minus 2x, but when we do that, they cancel out. And what we're left with is 6 equals 6. So is that a true statement? Last time I checked, 6 equals 6. So using our definitions, we know that our answer is infinite solutions. I know in our other class someone said, can we just write is? No, is what? Don't be lazy, write infinite solutions out. When your hand breaks off from writing too much in math, then you can start complaining. Okay? Cool. Number 2. Once again, we're looking for our variable that's by itself and what it equals, and find out where we're going to plug it. Okay? So, same thing. 2 parentheses plus 2y equals negative 2. And we're doing the same thing where we're going to plug in everything that x equals. X equals negative y minus 1. Now, when you get to this step right here, and if you have two different variables, I'm sorry, but you did something wrong and you need to recheck your work. Our goal right here is to cancel them out, okay? So we're going to distribute the 2. 2 times negative y gives us negative 2y. 2 times negative 1 gives us negative 2. And the rest stays the same. Okay, so let's find our like terms. Negative 2y and positive 2y on the same side. Those cancel out, and we're left with negative 2 equals negative 2. And once again, that is a true statement. So our answer is infinite solutions. And always put a box around your answer so Ms. Carranza or myself, when we're grading it, can tell what's your final answer. Okay? All right, let's look at example number 3. The x is all by itself. X equals 5 plus y. I'm going to find where the x is, and that's what I'm going to plug in. All right, so inside the parentheses, we're writing what x equals, and it said that x equals 5 plus y. All right, let's go ahead. Our first thing we have to do is to distribute. 3 times 5 is 15. 3 times y is 3y minus 2y equals 14. Alrighty, let's combine like terms. 3 minus 2 is y. Well, these didn't cancel out now. So now I know I have to solve. Okay? So we're going to subtract the 15. So the y is all by itself, and we get that y equals negative 1. So now that I know that my answer is going to be a point, we're looking for two things. We're looking for the x and we're looking for the y. And we know that y is negative 1. Now to figure out what x is, we're going to plug that in to one of the original equations where x is by itself. X equals 5 plus whatever y was, and y is negative 1. 5 plus negative 1. Hopefully you did that in your head. Okay. So we get 4, negative 1, and that's the point of intersection where those two lines meet. Okay, number 4. Once again, we got the x all by itself. That's what we're plugging into. And there's the x in our equation. So we're starting with negative 2 plus 4y equals 2. And then we're going to plug in the 5 plus 2y. Okay, let's go ahead and distribute. Remember, we're distributing a negative 2. Do not forget about that negative sign. Negative 2 times 5 gives us negative 10. Negative 2 times 2 gives us negative 4y plus 4y equals 2. Let's combine our like terms of negative 4y and positive 4y. Those cancel out, and you're left with negative 2 or negative 10 equals 2. Is that a true statement or a false statement? That's false. All right, so our answer is no solution. Okay, and for this one, there is a shortcut, the 0 with a slash through it. Okay. Alrighty. Number 5. Y is all by itself, and y equals negative 2 plus x. So let's go ahead and plug that in. We have 2x minus 2 in the parentheses equals 4. And we're plugging in negative 2 plus x. What do we have to distribute here? Well, we have to distribute the 2, but what type of 2 is that? Remember, it's a negative 2. Okay? So you have negative 2 times negative 2 is a positive 4. And then negative 2 times x is negative 2x equals 4. Okay? Combine your like terms. We have negative 2x and a positive 2x. And those guys cancel out. And you're left with 4 equaling 4. which means infinite solutions. All right, number 6. No freaking out because there are fractions in this one. Don't be a math weenie. We're solving for, we're substituting in for y. So we've got 8x minus 4 equals 12. Okay. And what we're plugging in here is the negative 3 over 2x plus 1/2. Okay, so as we start our distributing, because we have to distribute a negative 4, off to the side, write it. Negative 4, and if you want to keep it as a fraction, negative 4 over 1 times negative 3 over 2. Just multiply straight across if that's easier. Negative times a negative is a positive. 4 times 3 is 12. 1 times 2 is 2. So I just multiplied straight across to get my answers. And I'm left with 12 divided by 2, and 12 divided by 2 is 6. So our first term right here is going to be a positive 6x. And the next one is negative 4 times 1/2. Some of you might be able to do that in your head, but I'm going to show my work. So multiplying across, we get negative 4. 1 times 2 is 2. And then negative 4 divided by 2 is negative 2. That wasn't too bad, was it? Yeah, I didn't think so. All right, so let's go ahead and combine your like terms. 8x plus 6x is 14x minus 2 equals 12. And now we're just solving. So add 2 to both sides. You get 14x equals 14. And then divide by 14. We get x equals 1. Okay? So remember, we need a point, and all we know is that first number. Okay? I need to know what the other one is. So we're going to plug into the original equation. So y, or one that y is all by itself. So negative 3 over 2 times 1 plus 1/2. Well, 1 times anything is just whatever the number is. So we got negative 3 over 2 plus 1/2. The nice thing is the denominators are the same, so we can just add the numerators. Negative 3 plus 1 is negative 2, and negative 2 over 2 gives us negative 1. That wasn't too bad, was it? So our final point is 1, negative 1. All right, guys, 2 more, and then we're done. Okay, the x is the one that's all by itself, and x equals 20 plus 4y. So we're plugging in 20 plus 4y. Let's go ahead and distribute. 3 times 20, if you need your multiplication chart, it's on there. 3 times 4 is positive 12y minus 12y equals 60. All right, combine your like terms, and they both cancel. and then you're left with 60 equals 60. Our variables canceled out. We're left with a true statement. So that means infinite solutions. All right, last one. We're going to plug in for x because the x is all by itself. Now, don't forget about that negative sign, guys. That stays there. And we're plugging in 1 plus y. And the reason why we have to be careful about that negative sign is we have to distribute. We're distributing a -1 to both of those guys. Okay? So -1 times 1 gives us -1. -1 times y gives us -y plus y equals 1. Okay? So combine your like terms, what happens? Those cancel out, and you're left with -1 equals 1. Is that a true or false statement? Last time I checked, that's false. Okay, so if it's false, that means there's no solution. Okay? All right, well, good job. Those were your notes for 5.2, day 2. If you have any questions, please come see Ms. Carranza or myself. We would love to help you out. And now this 5.2 practice B is your homework. Okay? You should have plenty of time left in class, so please go ahead and get started. All right? Thanks for watching, guys.